I have wanted to visit the University of Minnesota Bee Lab for a long time. The Bee Lab's mission is to promote the health, diversity, and conservation of bee pollinators through research, education, and mentorship. I have heard so many good things about Marla Spivak and her work with the Bee Lab. I'm not sure if she would be the queen bee of the lab or the worker bee, as she has done so much good work. So thanks for letting us come to visit.
Thanks for having me. How fun.
Well, what is your background?
My background, let's see. Well, I was not interested in bees as a kid or insects at all. I became interested in honeybees when I was in college, when I was about 18 years old. And then I went to work for a beekeeper, and then I was hooked. They hired me as the professor of honeybee research. It's a long tradition here at the University of Minnesota. There's over 100 years of bee research at the University of Minnesota here. And I'm one in a long line of professors.
Marla, how did the bee research program get started?
Well, they began in 1913 with Father Francis Jaeger, and he started St. Bonifacius Church. He immigrated from Europe, and he also was the bee professor. And he stayed here until about the mid-30s, and then they hired another professor, Maurice Tanqueray, and then Dr. Haydak from Ukraine, and then Dr. Fergala from Canada. And then after him, I was hired in '92. So there's been a series of professors before me.
Well then, when was the bee lab actually started?
Well, we always had a lab. There was always a lab space in the Department of Entomology where I'm housed. But the honey extracting and other things were done in a little facility behind what's now the Bell Museum of Natural History of the university. And in 2015, we were able to get funding from the state to build this new facility. And they demolished that old cinder block building, and we got this wonderful lab.
So what were all the different groups or organizations that helped and contributed to getting this lab built?
Right. I attribute a lot of it to the Bee Squad, which is a program that I started here within the Bee Lab. The Bee Squad interfaces with the public. They're the outreach arm of our research and education lab. They really have an amazing reputation with the public. The public really knows about them and all of the educational programming that they do. And because of that, we started to accumulate a donor base. And when the university received permission to build a new building, the state said they would pay for 2/3, and we were tasked with raising the other third. And through all the goodwill of our donors and people we reach through the Bee Lab, they donated that $2.4 million to help get this lab built.
So how many people are part of the Bee Squad now?
Well, there's at least a dozen. There's 6 full-time and then a bunch of other part-time and summer help. And then that's separate from the bee research arm that we have. So it's honeybee research, and also inside is another professor, Dr. Dan Caravo, and he researches native bees. He's a native bee ecologist.
So how many hives do you work with now?
Well, Bee Squad has over 200, and we have 150 or so. So together, there's probably around 400.
What kind of research are you working on now?
Well, my whole career has been spent doing research on what we call social immunity, which is how honeybees keep themselves healthy, what their healthcare system is, basically. So honeybees live in a very densely populated colony, thousands of individuals, and how do they prevent disease transmission? What behaviors and strategies do they use to keep themselves healthy?
I have heard that there is a mite that really affects bee health. Can you tell us about that?
Right. A mite is like a little tick, and it sucks on the bees' hemolymph, their blood, but also their fat body tissue. It's an important organ in their bodies. It moves around, unlike a tick. It can feed for a while and then move to another bee, and it transmits viruses. It reproduces, this mite reproduces on the developing brood, the baby bees. It's called Varroa destructor. It has a great scientific name. It's very destructive, and between the damage the mite can do to weaken the bees and the viruses it transmits as it's feeding on bees, it's devastating to bee colonies. They were inadvertently introduced in the United States in the late 80s, so they've been here for quite a while. There are some organic insecticides, formic acid, oxalic acid, some lighter compounds that we can use to control the mites, but they're very difficult to control. One thing that I've been doing the whole time I've been here is breeding bees that can resist these mites on their own.
What are some of the other research projects that you're working on?
Well, the main theme is social immunity, or how honeybee colonies keep themselves healthy. And one of the ways they do that is called hygienic behavior. It's a genetic trait, and colonies that have this genetic trait are able to sniff out baby bees that are sick, and they sacrifice them. They toss them out the front door. But bees are able to sacrifice a few for the good of the colony. That's how they operate. We're trying to figure out, for example, if bees are detecting the baby bees that have a virus and they remove it, do they end up spreading the virus, or are they curtailing the spread of the virus?
So, especially in the spring of the year, do you have to feed the bees?
We try not to. There are some years where we do, but generally we leave enough honey on them in the winter where they're fine for the entire winter and into the spring. So I'm really interested in colonies that are able to survive on their own with minimum human intervention. I garden the same way with my native plants, by the way. I just prefer to do as little as I can.
Well, that was one of my questions, is I was going to ask you, what do you do with the hives in the winter time?
Right. Well, they stay right here. So a lot of these boxes are just full of honey that we will remove. And we leave about 100 pounds of honey on the colonies for the winter. And they'll work their way through that food all winter long. And then right here, we cover them with a black covering just to absorb some heat if it's sunny out at all. And they survive just fine sitting out here. Well, they cluster together in a great big group, and they shiver their muscles, and they generate heat. So if it's 20 below, it's 60, 70 degrees in their cluster.
So when they go back out in the spring, how do they tell each other where the food is?
Right. So there's scout bees that go find it, you know, the explorers, and they find a big patch of flowers somewhere. The first to bloom is maple, the pollen coming from maple trees. They produce a lot of pollen, and the bees are hungry for protein at that early spring. So the scout bees go out and they find it. They'll come back and they'll do a little waggle dance. And that informs their followers of that dance where those trees are. And those followers will go out and find it. That dance conveys distance and direction. It's quite remarkable.
What are the most important issues facing our honeybees today?
Right. When you say bees, I'm assuming you're talking about all of our bees. We have 20,000 species of bees in the world, at least. And honeybees are just one of those, one of 20,000 kinds of bees. Most of our bees are solitary, a few are social, like the bumblebees. But the main issues for all of the bees in general, they all need more flowers, so more nectar and pollen for their nutrition. They need fewer pesticides, so insecticides can directly kill them, not always. Fungicides, we're learning, can have effects on their gut microbiomes. And herbicides can kill the flowering plants that they need to survive on. They have their own diseases. Honeybees have these mites and viruses. Bumblebees, solitary bees, they have their own, diseases. But mostly what they all need, how everybody can really help all of our bees, is to be a gardener, to plant flowers that they like. And how do you find the flowers they like? You just go to a nursery or walk around and you say, whoa, that flower has a lot of bees on it. What's that one? And plant it.